I think the title of his talk didn't actually take part in the contest for the shortest title at the conference, because it is Clean Coders Hate What Happens to Your Code When You Use These Enterprise Programming Tricks. Let's welcome Kevlin Henney.
Right, good afternoon. Yeah, this is a shamelessly clickbaity title. I got carried away one day, and I have actually tried to give it another conference, but it wouldn't actually fit in the information slightly. They said it was too long a name, and they said, what's the short version of it? There isn't one. I've done a couple of things. I've got a very strong interest in how people do things, patterns, and how people do things well. But also, a recent discovery, well, I say recent, about 2 or 3 years ago, a discovery that problems in code arise not because people are being bad or stupid or evil. And in fact, it actually turns out when you ask people to write bad code, it's quite difficult for them to sit down and write intentionally bad code. But if you tell them to write in a particular style, if you say, I want you to assume a few things, use this style, suddenly they're able to generate the kind of code that we dislike. Or I hope we dislike. And the editor of 97 Things Every Programmer Should Know, which may or may not appear at this point, there we go. And style, therefore, is one of the things that dominates this book. But there's another thing I'm interested in. I also run a page on Facebook called Word Friday. It's about language and linguistics and words. I'm very interested in words and language. So occasionally when I want to understand a word, I will try and find out a little bit about its history, its range of meanings. So I thought, I'm using enterprise in the title, so let's find out what it means. Well, the problem is, I'm of a particular generation that whenever I hear the word enterprise, there's only one thing that comes to mind. You know, so, you know, I still kind of think it's like whenever people are sitting there and doing enterprise architecture, I go, come on, you know, and you've got the sort of the gorgeous reboot model. I was just like, this is great stuff. And actually, enterprise has been used as a hypothetical craft name for a number of things. This is sadly does not yet exist. But it's an artist's mock-up of what the first warp drive craft would actually look like. And it's a NASA idea. Those are actually warp coils. And you think I'm kidding? No, this is real. This is actually based on a theory by the Mexican physicist Miguel Alcubierre, who realized in 1994 that there are certain interpretations of general relativity that actually allow you to create warp drive. And that actually by using these coils, you will actually distort reality in a way that allows you to, as it were, cheat our perception of speed of light. You never actually break the speed of light. Okay? You cannot travel faster than the speed of light in space-time. But what you can do is make space-time move faster than the speed of light. Yeah? It's clever. It's a trick. Okay? And it's just as reality distorting as enterprise architecture. This is why I mention it. Okay? There is a reality distortion field. So let's actually dig through the dictionary, see what's going on. So a project or undertaking that is especially bold, complicated, or arduous. Yes, enterprise architecture is particularly this stuff. Readiness to engage in undertakings of difficulty, risk, danger, or daring. Yeah, this is getting it. A design of which execution is attempted. I love this, because it doesn't say, it says, well, we're going to try it. We're going to attempt it. Who knows what will happen? And then there's a bunch of others. You know, these are boring. We only want these, we only want these ones. Okay, so I'm going to talk about enterprise code. What is code? Okay, so code, we think we know what code is. Okay. Code is a set of instructions for a computer. We're kind of familiar with that one. Okay, that's good. A computer program, normally we don't deal with the lowest level. We use the term code to describe both the binary and the source. And they are both referred to as code. A system of words, figures, or symbols used to represent others, especially for the purposes of secrecy. You know what? You go around and you look at certain code bases and you think, that's the meaning of code they're using. I have no idea what this is doing. A set of conventions or principles governing behavior or activity in a particular domain, like a code of practice. And so so this is the interesting thing. This goes back to what I was saying. There was this realization, and I'll show you the code at the end, or the related code at the end, of a systematic code, a systematic set of practices that allows you to generate enterprise architecture, allows you to create these things. And this is a non-exhaustive list, but I'm going to, these are some of the common things, okay? Singleton configuration. Yeah, we're going to have one configuration and everything's going to go and see it. And it's going to be a singleton. And it's going to, in fact, you know what? It's not just configuration. It's singleton anything, in fact. If I can get this to working. Come on, there we go. Singletons. That's normally just a problem. Ironically, it's very rare that you will ever find a code base that has only one singleton in it. I find that ironic. The number of singletons in a code base is 0 or 2 or more. Verbose naming. You see, had I done this talk, say 15 or 20 years ago, I would not have put verbose naming in. I would have put abbreviated naming. I mean, we still have a few abbreviated naming problems, but these days, it's like some kind of inflation has taken hold. There's a hyperinflation in naming. We'll come to that. Noisy logging. It's just like, I don't know what to log. Well, let's just log everything. Okay? This is one of the things I've discovered. People often put arbitrary logging in because they don't understand what they need from logging. They never ask the question. They think they know what the requirements are for the functionality. But nobody ever sits down and says, what do we need from logging? What are our requirements from logging? You normally get statements like, oh, you know, just log what you feel like, or my favorite one, yeah, we know what our logging requirements are, to log everything. When somebody says our requirements are to log everything, you know they have no idea what they're doing. Okay? So I ask them little questions like, so you're logging the logging? No, of course we're not logging the logging. And I say, well, in which case you're not logging everything. You see, I have a very simple mathematical understanding of what the word everything means. And you're not doing everything, you're doing a subset of it. So then the question is, what defines the subset? And I will say things like, well, you didn't log the fact that you incremented a variable here, or that you allocated a variable here, or that you did this, or that you took this branch of the, oh, well, we're not logging all the things, we're not logging everything. Well, you just said you were logging everything. So there's this kind of idea that you end up with everybody's own little version of everything. And you end up with a lot of noise, and just where you need it is not where you get the logging. Repetition and duplication. Let me just say that again. Repetition and duplication. Because this is one of the most popular techniques. And we either do it by explicit copy and paste, or we end up seeing this by reinvention, familiarity, recurring structures. Unnecessary code. Just the dead stuff. It's just either the dead code or the code that is just noisy. In other words, there really is a short way to do certain things. And people sometimes find the longest way around. Mixed levels of abstraction. There you are, writing through a function. At a particular level of abstraction, you're talking business. That's great. Business. Boom, socket connection. What? Socket connection, mem set. What on earth has got, boom, business, bang, down. Mem copy. What is going on here? I mean, you know, great, roller coasters are fun, but really not in the code base. That's not where you want to see it. You know, you stay at a level and you say, okay, all that sockety and memory stuff, that's down there. Don't you worry about it at this level. We're talking business stuff, and you dip down. So mixed levels of abstraction. You give the reader a roller coaster ride. They will be very confused. Legacy coding habits. And this is one of the things, many of the languages that we work with, are either old languages that have got a history, and therefore it is possible to start programming in 1 decade at the top of a file and actually progress through time as you reach the end. Yeah? You know, one of the most extreme examples, I encountered a a client who wanted me to give them a workshop on test-driven development and some agile development last year. And I said, yeah, sure, fine, what language? And I kind of expected, because they do some numeric work, I sort of thought they might be doing some C, some C++. Fortran. No, I did not expect Fortran. That proved to be very challenging. I thought I left Fortran in the last century. But one of the discussions that we had during the day, they said, yeah, we actually have some Fortran that goes back to the late 1950s. Fortran was invented in the late 1950s. I mean, so, you know, this is a beautiful museum piece, but apparently it's still running. So that means they basically got code that smears through time, through the 50s, the 60s, the 70s, and 80s, the 90s, into the noughties, and now into the 20-teens. And it's just, wow, that's impressive. It just makes some of the C++ code bases I've seen look really quite young. So the point here is it's not just the code, it's the habits. And although you may be given a new language and you compile it, you still end up with the older habits. Sometimes you take on a new language, but your habits from wherever you've come from, they carry over. So we find a lot of this, and that's also builds up the unnecessary code and the noise. And then there's programming by coincidence. What does that mean? It means that sometimes things work, and really they shouldn't. Yeah? The talk after mine is on undefined behavior. Okay? And unfortunately, one of the definitions of undefined, the clue is in the name, it's not defined. One of the possible interpretations of undefined is it does exactly what you expected. And nobody questions it. Until maybe about 4 or 5 years down the line, you move platform, you change the compiler, or something happens, a small disturbance in the force. It's all it takes, and suddenly you're on the dark side. Okay, and there you are, you know, but you don't feel like a really cool Sith Lord, you just feel like you're debugging till midnight. So what is going on? So there's just stuff that kind of works, but actually, you know, and this is important, because one of the standard phrases that software developers use when you sort of say, when you point out something, you say, oh, I question that, you know, there's a better way of doing it. They will come out with the phrase, it works, as if that's all it needs. Well, yeah, it kind of worked that one time on this compiler, in that phase of the moon, but don't count on that in future. And then programming by superstition. Sometimes people have these strange beliefs. So, why are you doing that? Whoa, it'll optimize things. Really? Yeah, if you do this, it kind of speaks profoundly to the compiler, and it just goes a bit faster. So you do know that hasn't been the case since the 1980s. Yeah? Or some of the beliefs people have about exceptions and stuff like that. It's great. It's just, oh, you can't do it like that. Other great ones, we're not going to use the standard template library. Why not? Well, you know, it's not as efficient as rolling your own code, doing it by hand and stuff like that. It's like, you know, I actually did that with one client. As one of their concerns was that a lot of their developers were, they were C programmers, C programmers, Java programmers, some C++ programmers, but whenever they programmed C++, they always ended up with this, I mean, what I would call C+. You know, it's kind of, oh, yeah, but not quite. You didn't get the second plus. I mean, yeah, you're using a C++ compiler, and yeah, you've tightened up the type system, and you've got a few things. Oh, look, you've used the word class once at the top of a 10,000-line file. Well done. But sometimes you end up with stuff that you sit and they go like, well, what are you doing all of this memory management for? It's like, well, it's faster than using vector. So I did this example by showing how different the code was if you wrote it using something in the standard library or if you wrote it out longhand C style. And I had tests to prove that my code was correct and did the same thing. The final code was, the fully expanded version was something like 5 or 6 times longer and far more complex. And when I say 5 or 6 times longer, that is source lines. I'm not including the fact that some of those were curly brackets because the actual version using the standard library was mostly space. So we end up with these little beliefs, and those beliefs guide us. So what kind of enterprisey example am I going to try and explore? Well, you know, real software. FizzBuzz. legitimate, enterprisey. Okay, so FizzBuzz, quick show of hands. Who's come across FizzBuzz? Okay, a number of you. So a number of you haven't. Right. So the sink of all human knowledge, Wikipedia, says, FizzBuzz is a group word game for children to teach them about division. I have to say, when I looked this up on Wikipedia, I was very surprised. Because I know it as a drinking game. I am not entirely sure what kids are doing with this, but, you know. So, you know, there's a basic idea. Players generally sit in a circle. The player does, let's just pick out the important bits. Okay, what you're doing is you're going to count. 1, 2. Any number divisible by 3, fizz. 4, buzz. Any number divisible by 5 is buzz. Fizz, 7, 8. Now, if I say 9, I get it wrong, and normally there's a forfeit of some kind. If you're a kid, that means you no longer play, which I don't think works. It's not a good incentive model. If you're a child that doesn't like maths, then you get out of the game as quickly as possible. Yeah? So I don't think that works. Anyway, divisible by both. 14, FizzBuzz. Okay? So not exactly the hardest programming problem in the world. However, I found the most unusual thing about the Wikipedia definition was their use of the word thenceforth. Credit to whoever wrote that, because thenceforth is, I mean, if you can get that into a conversation, well done, because that is just not a word that we've used for like 200 years, okay, in English. I mean, thenceforth is really archaic, and it's just like, but it fits perfectly. I mean, you know, well done. I mean, Wikipedians, this is what happens when they get bored, okay? So, what do I know? Adults may play FizzBuzz as a drinking game, where making a mistake leads to the player having to make a drinking-related forfeit. Yes, this is more like it, but the best bit about the Wikipedia page, citation needed. Yeah, everyone was too drunk to kind of, you know, yeah. Anyway, so, things we know. FizzBuzz has been used as an interview screening device for computer programmers. But the best comment I saw last year, or a couple of years ago, FizzBuzz was invented to avoid the awkwardness of realizing that nobody in the room can binary search an array. It's just like, what are we going to do as an interview? I don't know, let's do FizzBuzz. You know, what about binary search? Oh, we always get off by one error, so let's just do FizzBuzz. Okay, so let's have a look at how not to do this. There we go. That's outstanding. I mean, this is a work of art. I had to really sit down and create this with some effort, but it's based on stuff I've seen. So let's walk through some of the craziness here. First of all, let's just go retro, okay? Let's just channel that kind of like macro stuff. Forget the const keyword, okay? And we're gonna so we're gonna put a constant in for fizz and for buzz, because you never know, they might change, which will never confuse anybody if you've now got a constant named fizz and it does something else. And then because, you know, it seems to be almost a rite of passage. You've got to put a null macro in there. Yeah, okay. Yeah, now it's a real file. Yeah. And then pi, because you just never know. Yeah. So, you know, it's a constant, isn't it? You know, there's not much of it, but you never know. We might need a couple of decimal places. Then we have, you know, let's go for meaningful names. Yeah, we could call it FizzBuzz. No, we're going to call it FizzBuzz Calculator. I mean, we could actually make the name longer. You know, you can use your creativity here, but it's just really. Then we're going to bunch all of the declarations up at the top so they can huddle like a family, which is great, but that's not how declarations are supposed to be. It's not cold in the code. They don't have to, they're not like penguins. Okay? And then we get some great stuff here. Oh, we've got our chart. We've got a buffer. How big should a buffer be? Well, I don't know. I'm gonna sprint F into it. So I don't know. 512? Oh, I don't know. What about 1024? Yeah, that sounds safe. So you know, that's the kind of reasoning that goes through. Then just to make sure it's all empty, we're going to zero it, because you just can't trust the compiler to do it itself. I did actually see a few years ago somebody wrote. I'm not going to say his name, but he wrote 2 articles that were about initializing a character buffer of fixed length. 2 articles and lots of template code. I remember my comment was, you can do this in one line in C. and it generates the same code that you've done. It's just like, really trust the compiler. They're pretty good at this kind of thing. Memset, if memset is the fastest option, the compiler will use memset. If it's not the fastest option, then why are you slowing it down? Let it do its business. Okay. And then, because this programmer, having worked happily in the 1970s and 80s with those macros, heard about lambdas, decided to go mad and just put it all on one line. So we got these crazy lambdas for doing the division. Then we got our range checking. Normally the problem is defined from the range to 1 to 100. Then we do our serious sprintf business because, you know, that whole C++ thing. And then we log to our unique instance, and if it's bad, and then we throw. So we log and throw, very popular technique. You know, that takes up a few lines. And then we have comments. I haven't mentioned the comments here. This is great. They just repeat what we're going to do. We use our lambdas. We do some more sprintf. And then we have this beautiful result statement that clarifies the name of the variable retval, just in case we hadn't figured it out. It's return value. It's in parentheses. And we say assign return value retval and return. What's the next line? Retval.assign. And the line after it is return retval. So, you know, that comment, just make sure it's all good. Okay, you just you know, just in case the compiler says, I have no idea what you're doing with the code, let me look at the comment. Oh, that's brilliant, thank you. Yeah? Okay, so this is a great observation. This is Paul Anderson. He was a science fiction author. He coined this thing called Anderson's law. I have yet to see any problem, however complicated, which when you looked at it in the right way did not become still more complicated. This is the manifesto for software development. Okay? And how can we do this? Oh, what are some of our favorite crazy examples in something like C++? Well, that code was the code that launched it all. It was the code that launched template meta programming. It was the realization by Irvin Unruh in 1994 that he could create a program that did not compile. And lots of people are going like, yeah, I can do that every day of the week. But his compilation message was the first few prime numbers. He discovered that templates were Turing complete. And then from that point on, the result has been anything but temporary. It's been permanently in certain code bases, and every now and then you're just looking at stuff and just there's a flock of angle brackets, and you're looking and I have no idea what this is doing. And your colleague will say, it's really clever. So what's it doing? I have no idea. It's like it's out of my short-term memory. Just don't ask me to do anything with it. So yeah, why am I showing this? Because you can do some really crazy stuff with, hey, FizzBuzz. This is by Adam Peterson, who used the Boost libraries to create FizzBuzz. And when it doesn't compile, it gives you FizzBuzz. See, that's far more interesting than most of the error messages you get. These days, sadly, C++ 11 and onwards have come along and spoiled our fun. It turns out we can do compile time compilation and stuff, and it's, oh, you know, we can do it all cleanly. We don't have to just sort of wallow in the mess that is template metaprogramming. Now, I've got here n modulo 3 and n modulo 5. I could reduce that to n mod 15, because that's going to be the same. But there's a reason I want to try and keep it here, because if you look carefully, what you'll realize, and this is one of the fun things about the FizzBuzz problem, is that there's seemingly no way of writing a FizzBuzz implementation where you do not do some repeated state check. So you're either going to say, okay, divisible by 3, let's add fizz to it. Divisible by 5, let's add buzz to it. So that means you feel really clever because you don't have to do the 15 case and you've used concatenation. The only problem is you still have another if to do. If something happened. Otherwise, I need the number. So you're always going to end up with some state dependency, some temporal ordering. Alternatively, you can have something that doesn't rely on temporal ordering but then leads to duplicate condition. Because effectively, we are testing 3 and 5 twice. So this observation was made, there's this wonderful paper and presentation by Maciej Pirog. The default action is executed only if some previous actions were not executed. So you know, the example that, as I mentioned before, there we go, there's our accumulation. Accumulate it. If it's empty, then do something, but we're still depending on it. Alternatively, I try and get really clever. I do this in a much more declarative style, okay? And I say, look, I've got an array, it's got empty, it's got fizz, it's got another array, it's got empty and buzz, and then the result is, well, let's just do modular arithmetic on each and concatenate it. But I still have to have the second check. I still have to go back and say, did something happen? So there's no way of avoiding these repeated checks. Or is there? Well, that was the whole thing. This guy did this in Haskell. So we ask if we can accomplish this without having to check the conditions for the previous actions twice. In other words, if we can make the control flow follow the information flow without losing modularity. So you have a perfect flow with no rechecking discontinuities or anything. Sounds perfect. Yeah, I translated the Haskell. It was quite fun. You know, if you really want to keep your job, this is how you do it, because nobody's going to get rid of you. So we've got fizz buzz. And I'm going to throw in a lambda, just for the hell of it. And that lambda is going to take a function object that takes a string and returns a string. And the lambda, well, the first lambda is going to do a mod3 check. And if it is divisible by 3, then it's going to return a lambda. So when people talk about higher order, this is what they're talking about. It's slightly confusing in that sense. So we're going to return fizz plus the execution of that function on empty. Otherwise, we're going to return the thing that was just passed in. And we've got buzz here as well. Yeah. And then we just do the things at the end. What we do is we have a function that just returns whatever it was given. And then we compose them together, and we chain them together. So that what we've got is the identity function. So when I pass in anything to the identity function, it returns it. Then it's passed to the buzz, which then returns a function that is dependent on whatever was passed in here, through to ID, through to the buzz, and then gets passed into fizz. So we've got this chain of lambdas that normally, at this point, you might find your brain is sort of leaking out of your ears, or you're falling asleep. I don't know which one. And you're thinking, either you're doing a sort of standard thing, in other words, what the hell is this? Or you're thinking, he's got duplicate code. And if you're thinking duplicate code, you're right. We can get rid of that. There we go. Let's have a go at this one. So here, I'm going to factor it out even further. So now instead of a function that just takes a lambda, it's going to take a divisor and a string and a lambda. And so it's really generalized. And it's obviously much easier to understand. And then I'm going to lambda this. I'm going to use bind, because I feel like I want to use a little more of the C++ standard library. So I'm going to use bind, and then I'm going to bind that together for 3. So I've got a fizzer, now I've got a buzzer, and then everything is as before. And you're done. And it's amazing. In just a few lines of code, we have reclaimed that lost territory of template metaprogramming is now dead, basically, for most uses. So where are you going to write your obscure code? Like this. Okay, this is how you do it. And this is how you create, this is how you create the kind of code that's so clever that you feel like you're an artist. Oscar Wilde observed a work of art is the unique result of a unique temperament. Please don't do this in your code. I'm only joking. Let's be very clear about that. I don't want you to walk out it's going like, wow, it's a really cool technique. Yes, it is really cool. Do it at home, but not at work, okay? One of the other aspects, on the opposite side of the clever range, is the cargo cult programming. Cargo cult programming is a style of programming characterized by ritual inclusion of code or program structures that serve no real purpose. So, what we end up with is a problem of signal-to-noise ratio. Okay? Signal-to-noise ratio is a measure used in science and engineering that compares the level of a desired signal to the level of background noise. We often use it as a metaphor to refer to the ratio of useful information to false or irrelevant data in a conversation or exchange or a code base. So, this is the classic. This is a great Twitter feed to follow, by the way, the expert beginner. What do those people in operations want from me? I'm already logging at the beginning and end of every method. Guess I'll do the middle too. It's just like, yeah, now we've got this perfect example. One of the other cases, and we've already hinted at this, is the way that people will often just comment stuff. And there's like, what are you commenting? Well, I'm just commenting what the code does. I'm just commenting it so anybody can understand it. I made this observation a couple of years ago. It's probably my most retweeted tweet. Common fallacy is to assume authors of incomprehensible code will somehow be able to express themselves lucidly and clearly in comments. Because if you think about it, what you're effectively asking somebody to do when you say, we need to please comment that code, it's not entirely clear what it does, I want you to comment it so that people can read it and understand it. Now, wait a minute, who's going to write the comment? The person who was unable to write the code clearly is now going to try and explain the code clearly. So suddenly it does happen. I have met people who have an incredible ability to explain things and to actually write decent comments and documentation. And yet their code is as obscure as the Lambda code I just showed you. But I'm going to say they're fairly rare. For the rest of us, it's a case of like, well, I had no idea what I was doing in C++, so now give me English. Yep, still no idea. And that's what you're left with. You've now got the same problem twice, but now everybody feels happy because you've got comments. Okay, what's the other aspect of cargo cult programming? You can also refer to the results of applying a design pattern or coding style blindly without understanding the reasons behind that design principle. Previously, I was very rude about Singleton, so I'm going to continue to be rude about Singleton. Singleton, there is actually a good Singleton. It is a whiskey. And I discovered I was clearing out, it's kind of tidying up my office earlier this year, and I found an empty bottle of Singleton. I also found my next door neighbor gave me a bottle. He said, oh, did you know there's a bottle of cider with your surname on it, and it's possessive, Henney's, that's great. And then my wife gave all of us in the family those customized Coke bottles. So that's Kevlin Henney Singleton. If you want yours, you get your own, okay? That's my one, okay? But this one is actually better for code than the one you put in code, yeah? It'll cause you to think reasonably. So, but it does lead us into this kind of cargo cult programming style. This was a thing that appeared on Bonkers World last year. The world seen by an object-oriented programmer. And you had, this is the naming gone mad. This is exactly what I was talking about. Look, there's a living space separation decorator, a visitor monitor interface. One of my favorites, the multi-butt supporter. And there's also the entertainment provider Singleton. It's just like, oh, dear God, no. And this is the problem. We've ended up with what might be called homeopathic naming. In other words, we keep diluting the names by making them longer and longer. And people say, I'm just making it more meaningful. It's just like, no, it's like, you're not going to make the whiskey stronger by adding water, okay? So, this is an easily solved problem. One of the ideas behind object orientation is you say, hey, look, that's a door. You can't call it door. Everybody will understand what you're talking about. Look, put some other things in front of it, like controller or interface or some other wording. So one of the other things I'm interested in is actually writing fiction, short fiction. And there's a book that has a series of prompts and cards to try and get you to focus on things. And I found these were quite relevant to code. Choose the right name. Get specific. The problem is that sometimes people try to overgeneralize. And the thing is that nobody wants overly general names, and they also don't want overly general code. This is where a lot of complexity comes from. People don't have general problems. They have specific problems. If you have customers that have general problems, I want those customers because they're great, because they'll, what they're going to do is they're going to contact you. Hey, we need some software. Oh, that's cool. What would you like it to do? Oh, I don't know, something really general. It's just like, that's brilliant. Just send them an operating system because that's so general that you can build anything out of it and with it. Here is a compiler. From that, you can build the universe. Okay, it's so general that you're able to customize it. Well, how do I customize it? You configure it using a special configuration language. What's the language? It's called programming language. And you can then make it do anything. So get specific. Don't be afraid to be specific. Now, when it comes to naming, our current troubles are not actually that modern. One of my favorite books of advice actually comes from outside the C++ world. SMALLTALK best practice patterns from the mid-1990s. And Kent Beck, he observed back then, he was saying, look, people will be using the words you choose in their conversation for the next 20 years. We are now at that point, 20 years on from when that book was published. You want to be sure you do it right. Unfortunately, many people get all kind of formal. Just calling it what it is isn't enough. So what do we end up with? They have to tack on flowery computer science-y, impressive sounding, but ultimately meaningless word like object. Any class that ends in the word object is, no, really, honestly, it's blindingly obvious it's a blah, blah, blah object because it's a class. I mean, I can't say it fairer than that. Thing. I've seen that. I've also seen stuff in code. Component, part, manager, entity, item. These are all really popular. And they were popular back then, but not as popular as they are now. And I had this interesting, this is actually relates to a client visit that I had. This is my recollection of the code, although I'm pretty sure they didn't get it const correct. So, but I do remember the bits that are correct. They had a class at the root of a hierarchy. It was only a pure interface of one function. The dot dot there is to cover the virtual destructor. Pure virtual. And the class was called condition checker, which sounds meaningful. I mean, it's got lots of syllables. It sounds like it's a proper word. It's describing things. And then you have a single function, check condition. It seems very self-explanatory, but I remember asking them when we started looking through the code and the hierarchy, it's basically checking rules. Is something true, in which case we fire an event, otherwise, and you're able to compose these rules. So I'm looking at it, it's just like, wait a minute, what does this really do? And I talked through it. I said, you mean it's a condition? Yes. And you're checking whether or not it's true? Yes. Right. That's what it is. It's a bit like the bit in The Matrix where Morpheus says to Neo, stop trying to hit me and hit me. It's not a condition checker. It is a condition. You're not checking the condition. It's true or it isn't. It really is. We keep adding these extra levels of indirection. I'm expecting one day to go into a code base, check to see if it's okay with you, if that condition is true. And the full name is there. And then probably put equals equals true, just to be sure. Yeah? I believe the Italians call that la vera verita. It's the true truth as opposed to the false truth. Yeah? But you've got to be really, really sure. You've got to check that condition, because it might move around when you're not looking. Anyway, the great thing is C++ 11 onwards, it's just like you don't need any of this. It's just like boom, just disappears in a puff of lambda. And it's actually quite simple, not the lambdas I had earlier. Okay, so we need to worry about tidying things up. We need to worry about clearing things up. So I want to walk through kind of this kind of area, this question of refactoring. And refactoring is something that is often abused as a term. I've had discussions with people where they've used the word refactoring as I observed. I said, wait a minute, you're just using the word refactoring to mean change the code. And I said, that's not what it means. And they said, oh, well, you won't have any effect here, Kevin, because that's how we use the word. So, these guys would be sitting there and you'd say, what are you doing? Refactoring. Because that's what they're doing. They're touching the code. They're doing something. And you'd say, well, what kind of refactoring? Well, I'm trying to make it faster. Well, that's called optimization. Your performance tuning. I'm trying to fix a bug. That's not refactoring. I'm afraid that's just called bug fixing. We don't have a really cool name for it. I'm sorry, okay? So the thing is, it turns out we've already got names for a number of activities. And refactoring as a term, it goes back to Bill Opdyke about 25 years ago. Funnily enough, in C++, people have kind of forgotten that there is a history there. And it turns out C++ is one of the languages that has the most rubbish tools for refactoring. But it does have a precise meaning. It's a change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. I want to come back to that because I want to be a bit more precise about what Martin means by observable behavior here. And therefore, to refactor is to do this, to restructure software by applying a series of refactorings. Now, of course, when you refactor things, you're not just improving the code, or hopefully not just improving the code, you could be making it worse sometimes, as we've seen. But there is an idea of the behavior. What is the behavior that is unchanged? Because clearly it might get faster, it might get slower. And that's not what Martin is referring to. And now, a number of years ago, I felt really uncomfortable with, I realized I was very uncomfortable with one of the most common phrases that we have in coding, in software development as a whole, is the idea of non-functional requirements and the non-functional behaviors of a system. And I'm just to let you know, that is just terrible English. I'll just think about it for a moment. You've got functional requirements. Okay, this is good. You've got all these functional requirements, and then you've got these other requirements. What are we going to call these? I don't know, they're not those. Do we have a better name? No. Okay, let's call them not the functional requirements. That's a bit long. Let's call it non-functional. Problem is that the word non-functional in English already has a meaning. It means broken. It means not functioning, as the name suggests. Yeah? So when people say, what are your non-functional requirements? I want it to crash every Tuesday. I want it to not work. Okay, I want it to not work, because that is a non-functional requirement. I want it to be out of service for the whole of Tuesday. That's not what they mean, it turns out. So it's a complete failure of naming, a complete lack of imagination. Okay? But also, it actually groups lots of different things together that are coincidental and are not actually the same. So, for example, and this is kind of one of the kind of classic example. I think I've taken it from James Gleick's book on chaos. Just imagine going to the zoo. I went to the zoo. What did you see? I saw elephants. Oh, cool. What else did you see? I saw non-elephants. Tell me about the non-elephants. Well, there were some really big non-elephants, some really small ones. There were ones that flew. There were ones that swam. There were non-elephants that liked the cold and non-elephants that liked the warm. It's just like, you know what? We might be missing something about the domain here. A certain richness and texture to it. So, yeah. So, one of the observations came up with it is you can do this as roughly a right-hand rule. Okay? What you can do is you can separate out a number of aspects. Functional behavior. Okay, that's the semantics. Well, this is all good. This is the stuff that passes or fails the unit tests. Operational behavior is how it operates, how it runs. Does it run fast? Does it run slow? What's its availability? How does it scale? It's all of those ilities. But importantly, those are the runtime ilities. Those are properties of the system at runtime. And therefore, they are in some ways like the functional ones in that they can be experienced by a user. They can be experienced in the running product. And then we have these down here. Developmental. The developmental aspects of a system, some of which we may have requirements about, are the aspects of what is it like to be in that code? What is it like to live in that code? What is the quality of the code? That's your portability, maintainability. This is properties that developers experience, not the users of the system, but developers. And grouping those together doesn't help us because it's really those guys that need to be together. So refactoring, when we say it doesn't change the behavior, it doesn't change the functional behavior. What we're doing is we're trying to keep that vertical axis the same and stable. Don't break the code. Then the developmental axis we're trying to improve. The operational axis may get better or worse. It may go faster, may go slower, may use more memory, may use less. And obviously, once you've got this model, you've got a really simple way of talking about things like performance improvements, such as, I'm going to improve the performance, the operational axis. But what happens to the developmental quality? Oh, by the way, do keep the functional axis the same, because otherwise you end up with that kind of classic problem of like, well, it runs really fast. Yes, but it runs incorrectly. Yeah, but the bugs run really fast, don't they? And it's just like, no. So the idea is that both are functionality-preserving transformations, but flip through 90 degrees. So let's go and have a look at some code. The code that kind of inspired me, or rather, I accidentally recreated my client's coding style by making just a few simple assumptions. And so we've got a function here, and so I want to zoom in. Let's have a look at what we've got. So we've got a function called create server connection, returns a pointer to a connection. We've got a bunch of declarations up the top. Then we've got some checking. We're going to get the address from a configuration manager, check it's okay, do log and throw if it's not. Same again, more of the address. And then, same again, yeah, keep on going, and something actually happens. Now we're going to do a conversion, port to bytes. Oh, look, interesting, A to I, and I'm using data of the config port, which is a string. Ooh, I'm not sure about that. I was beginning to get worried. I hadn't seen a log and throw for a while, but it's okay, there's one there. And so we're going to do that. We're going to actually create the damn connection that we said we were going to do. And we're going to do lots of checking on it. We're going to check that the result of new is actually not null. Yeah. And then we're going to ask, are you okay? Are you all right? Are we good? Yeah? No? Oh, okay. Log and throw. And then And just to make sure, because it's such a build-up, it's like practically a film finale. You know, the ship's exploding at the end. We've got a comment: return the connection, because it's not obvious what we're doing. Okay, so let's just go through this. The first thing I want to draw to your attention is actually the thing I didn't say: the comments. Dear God, the comments. If you end up writing code that comes in sections and you put a comment at the top of every section, effectively you are naming a block. It turns out there is a really cunning little feature in C++ for naming blocks. It's called a function. I know. You know, this is straight out of 1970, okay? So really, what we want to do, it's not that you never want a comment, it's just that if you are simply compensating for other negative aspects of the code, then that's not a good comment. That comment is there trying to kind of hold the thing up. But actually, I'm not just going to delete the comments. What I'm going to do is I'm bugged by the fact that there's bad grammar and bad spelling in there. So I'm going to fix that first of all. Okay, so we're going to fix the spelling and we're going to fix all the mistakes and then we're going to delete it. Okay, it's tidy. Okay, so you know. So yeah, it just makes you feel more comfortable. Check that version in and then check the next version in. Poof, it's gone. Right. So now the next thing we're going to do is those declarations. They were huddled at the top of the function. It's like they're scared of the code. Okay. Let's distribute them amongst the code. Let's just move them down, and the code becomes, well, shorter and more logically structured because we've moved everything to its appropriate point. We moved everything closer. Also, I'm going to sort of take advantage of the fact that auto does an awful lot of work for us. Sometimes, I mean, some people, it had got to the point a few years ago when auto was initially introduced to do automated type deduction. People say, oh, you're messing with the type system. No, really, you're not. The compiler knows the type. You know the type. You know it. Why are you typing it out again? Why are you having to do this ritual? And with some of the type names we get these days, they get really long. And in fact, some of them we don't even know. So therefore, I'm going to go with that. If something is not obvious, then we need to make it clearer. But normally, the idea is you want to make your code more obvious. You want to improve the obviousness so it's clear what the intent of the right-hand side of the declaration is. You don't need to worry so much about the left-hand side, just as we want to improve it so we don't need the amount of comments. So let's zoom in a little bit. So yeah, we've got some legacy coding practice here. There's this kind of whole let's just check that new. It's just like, really? I think I'm going to get rid of that because new does not return null. It's as simple as that. And when people say, well, you know, it does do on some compilers, I get this every now and then. And I ask people what compiler they're using. And then they sort of say, oh, I'm using GCC, you know, or I'm using Visual Studio. And I say, oh, right, so you're using Visual Studio 4. They say, no, I didn't even know the numbers went down that low. You mean this was like, you know, 4 AD? No. They were numbered. They weren't just years originally. And so there's this idea of like, actually, it hasn't done that for so long that the world has changed in that time. So really, just go with it, because trust me, if you're having to check for null, there are far worse things you should be checking for. Okay, now, there's a little bit of a thing going on here, because let's have a look at that. We've got this raw pointer floating around. There's an allocation there. It's just like, So some people are like, well, look, we've got a thing that does that. Auto pointer. Stand aside, non-C++ 11 person. I've got something better. And so you're going to go, yeah, I've got a unique pointer. Or I would if this pointer doesn't work. And so we go, yes, make unique. Actually, this is one of the subtle things. This is the wrong time to do this refactoring, because that refactoring ends up with a signature change. So what I'm going to do is I'm going to change the internal stuff before I start changing bigger stuff. So actually, I'm going to be a little more modest. I'm going to say, right, I'm going to keep the external API stable, and I'm going to use unique pointer internally, and then I'll release at the end. So in other words, be very careful. There is a natural kind of sequencing to refactorings that means you don't break the universe, at least not all the time. So let's go back to the big picture. What have we got here? Well, there's a few bits and pieces. Let's zoom in on a couple of things. So config address.data, I feel very uncomfortable with that because data from a string is not guaranteed to be null terminated. Now, it's very unlikely you're going to find an implementation that doesn't do that, but this is programming by coincidence. It's not intended to do that. So there's this idea of like, actually, it should be C-string. If you want it to be null terminated, then it should be that. But if you look more closely, it's like, why are we doing this at all? A to I, that's a C function. We already have S to I in C++ 11 onwards. So therefore, I don't even need to worry about .data and .C-string. I keep finding people trying to wrench the poor beating heart of C out of their C++ objects. And it's just like, let it be. It's okay. They're good. So the next thing is then starting to look at the sprintfs. And it's really funny because people just get into a habit, and these are kind of copy and paste lines. And you look at sprintf buffer, we've got the magic 1024 up there, and then we've got the message %s, and then we look and we think that's really funny because we're doing the same thing. Basically what we're doing is string concatenation except for the one at the bottom. It's like, well, hang on, isn't there an easy way of doing this? And is there a safer way of doing this? Well, first of all, yes, we can make it safe. In other words, actually not run the risk of buffer overruns. Let's use n, let's use snprintf to actually make sure that we don't run off the end of the buffer. And your colleague will go, no, but that's why I made it 1024, to make sure we'd never run off it. Yeah, because of course, 1 kilobyte is just like, yeah, nobody's ever accidentally going to run off the end of 1 kilobyte. He says, looking at his multi-gigabyte machine, it's like, no, nobody ever does that kind of mistake. So, yeah, so we do that. But then if we zoom in a little bit, it's like, well, hang on, we got this. We're just concatenating strings. This is all we're doing. And that string up there is actually constant. This is the funny thing, is when you start looking closely at things, you realize, you know what, we could just get rid of some of this stuff. We can first of all make it safe by using string stream, but then we can start getting rid of stuff and realizing that one is actually a static string, and this one can use ordinary string concatenation. Why are we using smprintf or string stream at all? Okay, so if we zoom out again, things are looking a little bit tidier. But what I've done here, there's a number of different paths we could take at this point. Now, sometimes people will say, well, let's try and rationalize the logging. Let's attack that. Sometimes the best thing to do is say, I really don't like that log and throw technique, but what I'm going to do is I'm going to put it to one side. I'm going to have a function fail to connect, and that will do log and throw. Okay, so in other words, I don't like the log and throw, but we're going to do it, and I'm going to wrap that up. And that now reduces everything to one-liners. And because I'm rebellious like this, I'm going to get rid of those damn curly brackets. Because, oh, the code gets readable. There's this interesting idea that we should always put curly brackets absolutely everywhere, and sometimes it becomes ritualistic, and there is a good reason that people do that. But I like the alternative way of looking at this, which is perhaps I should try and make the block one line long. In other words, why is it longer? In other words, challenge yourself the other way. Why have I got a longer block here? Can I make it shorter? Particularly for these guard style clauses. So now we're getting something that's much, much shorter. So there's a little bit more tidying we can do here. So we kind of zoom in, and there's a few other bits and pieces. So one of the things I'm now going to start doing is I'm going to start, at this point I feel comfortable enough to actually make a signature change. So let's go and make the signature change. Let's go back to, let's actually transfer ownership explicitly in a way the API makes it visible. The next thing I'm going to do is I'm going to get rid of this kind of like object-oriented assembler. You can always spot object-oriented assembler. It's kind of like get and set and create and stuff like that. Create server connection. That's not what you want to do. And you might say, well, yes, it is. I want to create server connection. No, no, no. What do you actually want to do? What are you really trying to do? What I'm trying to do is connect to the server. That's what you're trying to do. That involves the creation of something, but don't tell everybody about the mechanics. Tell them what your intent is. The intent is connect to server, which also, by the way, happens to be shorter. And at this point, we can go, okay, right, let's have a look at this Singleton configuration. First thing I'm going to do is configuration manager, get value. Okay, first of all, it's a value of. Stop getting everything. I'll talk a bit more about getting tomorrow. Stop getting everything. Just it's a value of something. That's what it is. You're not getting anything. The next thing is it a configuration manager? Or is it just, I don't know, the configuration? Oh, I can tell what it's doing now. It's actually the configuration. That's what we're talking to. We don't have a manager that's been controlled by an entity that at a level of indirection that's, no, it's actually the configuration. So we've tidied this up. But if we look closely, we will realize that why are we doing all this processing in here? Why don't we just pass them in as arguments? 2 string arguments. There we go. There's the configuration address. And so in other words, what I've done is I didn't need to do all that stuff on the Singleton configuration because it turns out that we shouldn't have been using Singleton anyway. Parameterized behavior using wait for it, parameters. That's why they're called parameters. Parameterized behavior. It's just like, wow, functions were built for this. So pass that stuff in. And then if you look carefully, you'll see there's a lot of stuff to do with string conversion. And if you pause a moment, you think, well, hang on, why are we passing in strings? Why doesn't the caller sort this out? Why are we having to do this? And this is probably being repeated elsewhere in the code. So we're going to come back to that and just realize, what we've got here is this. It's like, oh, most of the code disappeared. Because what we've actually done is realize that we're working with the wrong types. Most systems we find these days are what we call stringly typed. And so there's an awful lot of work going into conversion and validation and conversion and validation. Of course, if you are getting paid for the line of code that you write, ignore everything I've said. But the point is, you want to get those types as early as possible, bind them to the right thing, bind them to the right abstraction. In this particular case, we already have a Unix level abstraction, and it's just like, right, oh, that's it. So now what we're doing is we are talking to the object, we're creating it, and then we're going to ask it, are you okay? And then we're going to do a fail to connect. But why are we having this dialogue with it? If it failed, it should throw an exception. It shouldn't be create the object and then forget to call OK on it. It should just be this. So if it fails, it fails. A constructor is not simply an ordinary function. A constructor is a special function. It is a transaction. And like a transaction, it either completes and creates a new valid state of the system, or it rolls back to give you the previous state. In other words, it aborts with an exception. So it's a special kind of function. So if this succeeds, we get a connection. If it fails, we get an exception, and the world hasn't changed except for the presence of the exception. And at this point, we realize there's no point in having this function at all. Thank you very much.
How would you recommend to replace the log and throw pattern?
The log and throw approach, I think, is one of those cases of the first thing I would do is find out what people want from their logging. And that's actually a surprisingly hard question, because often we will use the code as a way of recognizing there is a problem. And then instead of trying to solve it as a coder, try and solve what do we want from it? Because often it's a log and throw is probably not the right thing. Normally what you want to do is get out of there, and somebody else up here is responsible for logging. The problem is one of the things we find is that logging gets coupled into lots of lower level code. And the idea is you're supposed to, and this is why it unwinds the hierarchy, get to the point where somebody can make a policy decision. At this point, this logs because we have a business meaning for what just failed. And the content of the exception tells us what happened. The problem is we do it too close. We think we must do it there. So there's this kind of idea of, we've ended up with a kind of a sense of like, oh, something's gone wrong, we must do something, so therefore we do everything. And so the first thing is actually not to tackle it, use it as a recognition. It's a smell. It doesn't give you a solution, but use it as a smell and say, well, what do we actually want here? And then find out what people want from their logging. Because you may find it's not the same as the things you're going to throw an exception about. And so that's the problem, is a lot of logging ends up being very developer-centric, but too code-centric. It's not system-centric. So find that out, and then make sure that you have a more separated policy. In one little code base I worked on, I ended up using a plug-in approach, because I really wasn't sure. So it was also like not so much a microkernel as a nanokernel. As a piece of code, you'd plug stuff in, and you'd say, look, bad things happen. It calls this. Maybe it throws an exception. Maybe it logs. Maybe it uses some other callback. The idea is that the core code remains fairly straightforward, and something bad happened. I'm going to tell somebody, and then maybe I'll continue with it. So what you do is you invert it to compensate for the indecision. So all the indecision goes on the outside of the code instead of the inside.
You're invited to use the break to ask Kevlin any additional questions. Big thank you to Kevlin Henney.
Thank you very much.